The next operation on set will be the union of two sets. Now, the union of two sets, unlike the intersection of two sets, is when we bring the two sets together. All the members in the first set and all the members in the second set will be joined together. An example is if we have the set A, which have the members 1, 2, 3, 4. Then we have the set B, which have the members 3, 4, 5, 6, 8. Now, these two sets, even though they have an intersection, that is not what we are concerned about. Our concern is to unite or union these two sets. In order to union them, we will bring them together. So A union B, as the symbol will go, U for union. So A union B, that is the set A union the set B, will be 1, 2, 3, 4, which are the set A members. 1, 2, 3, 4. And then you realize that 3 and 4 are members of B. But when you are bringing them together, please don't repeat 3 and 4. You just maintain them because they are already there. So 3, 4 will continue. 3, 4. Then 6 will come, 8 will come, and 10. This is what we call union. And please, I repeat, when 2 members or any of the members are repeated in a set, please don't repeat them in the union set. Just make sure they are just the single ones. So for example, 3 and 4 here, 3 and 4 here. When it came to the union set, 3 and 4 were just once in the union set. So you have to take note of that. So A union B is giving us these members. That's how we unite or we union set. Now, A union B means A union B, whereby the symbol U means union. That is what you have to take note of. So the union symbol is U. So this is what we refer to as union of sets. We want to see how we illustrate union of sets in a diagram form. So if we have two sets A and B, if they have a union, the first diagram that can qualify to be just like the union set will be this diagram, figure 1.4, where the set A and the set B are subsets of the universal set. So they have a union and still an intersection. That is to say, they are having an intersection. A member or some members in the set A can still be found in the set B, but yet we can unite them or we can union them. So that is what the first one is saying. But the second one, they are disjoint, meaning they have nothing in common in terms of their intersection. No member in A can be found in B, but yes, so the set A and the set B can be united or can be union. That is what is found here in the diagram or figure 1.5. Now in the figure 1.6, you see that the two of them are having an intersection and still a union. Another way of drawing it. So this one can still be drawn like this. So the figure 1.4 can still be drawn like the figure 1.6. This is another way of drawing it. So these three diagrams depict the union of set. And the sets are A and B. Thank you. Now it says that in the question, if Q is equal to 7, 8, 9, 10 and R is equal to 5, 6, 7, 8, find Q union R. Now to solve this, let us put down the members of Q. We have the Q members as 7, 8, 9, and 10. Then let's put down the members of R. We have the R members as 5, 6, 7, and 8. Now, let us check. We want to union them. So Q union R will be bringing them together. So that will be 7, 8, 9, 10. 5, 6, 7, 8. So the least member for the 2 will be 5. So start at 5, then we get to 6, which is the next one. We get to 7. There are 2 of the 7 here, but we'll just repeat one of them. So 7, we have 8. 2 of the 8 here, but repeat one of them as 8. Then we have 9, and then 10. You realize that that is how it's going to be. So 5, 6, 7, 8, 9, 10 will be the union of set Q and set R, referred to as Q union R. So this is how it is done. So please take your time, go through it all. And don't forget that anytime there are repeated members, please, you bring them one. For example, 7 was repeated. So 7 is just once. 8 was repeated and 8 was just once. So please take note of that. Don't write them double or don't repeat them here. Just a single one. Thank you very much. The next type of operation of sets is what we call disjoint set. Now, disjoint set happens to be the opposite way of intersection of sets. What do I mean? I'm trying to say that disjoint set is a condition or it's the situation whereby two sets do not have any member or any element in common. That means if you have a set and another one, there will be no member in the first set, that will be in the second set. To illustrate this one, let us look at the set P. P is given as 1, 2, 3, 4. These are the members in P. And the members in Q, we have 5, 6, 7, 8. Now, if you check the members in P, and you compare it to the members in Q, they do not have anything in common. So we can now conclude and say that P intersection Q becomes an empty set, which is this or this. So it is a null set or an empty set, meaning there is no particular member in P that can be found in Q. Then we call those two sets disjoint sets. Another illustration can be A and B. The set A has 1, 3, 5, 7 as its members, and the set B has 2, 4, 6, 8 as its members. If you check clearly from set A, there is no member in set A that can be found in the set B. So that means that the set A intersection B is an empty set, or there is no member, making it a null set. Since it is a null set or an empty set, then we can conclude that set A and set B are disjoint sets.